Good evening, friends. Good evening, friends. Good evening. All my dear my dear friends. Good evening, everybody. Good evening, everybody. Murali sir, good evening. Karthik, good evening. Abhishek Thakre, good evening. Sunil, good evening. Ashwini Kumar, good evening. Lalit Mahavar, good evening. Satish, good evening. Sandeep, God bless you. Kavya, good evening. Dear friends, please confirm once, am I clearly visible and audible? If you confirm once so that we can start the session. Navya Sri, good evening. Dear friends, please reply in the chat box. Suresh, good evening. Lakshmi, good evening. Please reply in the chat box. Everything is clearly visible and my voice is audible or not. And the screen is also visible or not. Please reply once, my dear friends. Lalit, clear all. Saurav, good evening. Okay, dear friends, let me start the session without any time waste. Yeah, all people are given reply that clear. Sandeep, sir, allow us to post doubt in Telegram. Okay. Definitely, Sandeep, I will work out on this after the class. Let me continue the session. Right, question is there on the screen. The question is there on the screen. Yesterday we discussed about line to ground fault. Now please give the answer for this question. Murali sir, thank you. The question is that pre-fault voltage is measured as 34.5 kilovolts. Pre-fault. What is the meaning of pre-fault? Pre-fault means before occurrence of the fault. The before occurrence of the fault, where the fault is occurred, end of the transmission line. First of all, one thing we have to remember this, that is synchronous generator is connected to step-up transformer, then connected to transmission line. At end of the transmission line, there is a line to ground fault. Am I correct? And synchronous generator is going to be star connected with reactance grounding. And one thing I have to represent here is, small mistake is there, typing mistake. It should be 11 kV, not 1 kV. It is 11 kV. Please correct all of you. And generator is working at 30 MVA capacity, that is the power. And LV side voltage of the transformer is given as 11 kV and HV side voltage of the transformer given 33 kV. Therefore, the voltage of the transmission line also going to be 33 kV. I will repeat once again. Synchronous generator is generating 11 kV, LV winding voltage also given as 11 kV and HV winding voltage also given 33 kV. Now tell me, what is the voltage of the transmission line is also going to be 33 kV. Am I correct? Reason, there is no transformer between HV winding and transmission line, therefore voltage at the fault point also 33 kV. But actually this is the voltage at the fault point. But he said one thing, before occurrence of the fault means pre-fault voltage is measured as 34.5 kilovolts. Am I correct? Let us concentrate right now how to calculate induced EMF in per unit. Induced EMF in per unit, already yesterday only we discussed how to calculate per unit value, actual voltage upon base voltage. Dear friends, at the fault point he measured initially as 34.5, which is nothing but actual voltage. Very important, I am going to tell one point right now. The base voltage we have to select as a generator voltage or the voltage at the fault point. Please reply in the chat box. Please reply in the chat box. Srinath, good evening. Please reply in the chat box. The voltage at the fault point is 34.5 kilovolts is said, And what is the base voltage that you have to select? The base voltage will be selected as generator voltage or else voltage at the fault point. Already in per unit representation I explained, wherever fault is occurred, at that point we have to take voltage as the base voltage. The base voltage is going to be taken as 33 kV because the fault is going to be occurred at 33 kV. Therefore, the base voltage which I am assuming here is 33 kV. Now tell me, anybody can give the answer. What is the pre-fault voltage in per unit? That is ER1 induced EMF in per unit, 34.5 kilovolts upon 33 kV, which is 1.045 per unit. This will be the induced EMF. But already said induced EMF is always 1 per unit. But in this question, he given, what is given? Before occurrence of the fault, he measured voltage at the fault point as 34.5 kV and the actual base voltage will be selected at the fault point. Whatever the voltage is present at the fault point will be selected as base voltage. Therefore, the base voltage is going to be 33 kV. Am I correct, my dear friends? Now, induced EMF in per unit is completed. Now, question is, calculate fault current in per unit. Is asking calculate the current in per unit, voltage of the neutral also in per unit. This will be the question. First, tell me, one thing I have explained very clearly in case of fault analysis, symmetrical components. In symmetrical components, positive sequence reactance and negative sequence reactance both are equal in case of synchronous generator, and transformer, positive sequence, negative sequence, zero sequence, all the reactances are equal. Therefore, XT1, XT2, XT0 all are given equal. In case of transmission line, positive sequence, negative sequence are equal. Zero sequence is approximately 3 times of positive sequence. Already I have explained all these concepts in case of symmetrical components. But now you have a question, sir, in case of synchronous generator, you said positive sequence, negative sequence are equal, zero sequence is less than positive and negative sequence. No doubt that zero sequence is right now 8%, which is less than positive and negative sequence reactance. This is perfect, okay. Now question is, the reactance in the grounding is given as 5%, but why negative sequence reactance is less than positive sequence reactance? I already explained. In case of salient pole synchronous generator, in machines class you studied, in case of salient pole synchronous generator, due to projected poles, there will be a non-uniform air gap between stator and rotor field winding. Whenever there is a non-uniform air gap which is present between stator and rotor field windings, what I have explained? Negative sequence reactance will be less than positive sequence reactance. This is the concept, right? Sai Tarkesh, good evening. Sujal Kumar, good evening. Ashwini Kumar, salient pole synchronous generator, very good. Salient pole synchronous generator always have negative sequence reactance is less than positive sequence reactance. Now tell me, where fault is occurred at end of the transmission line. Therefore, synchronous generator is delivering fault point, current to the fault point through the transformer as well as transmission line. Now, we need to calculate equivalent reactance with respect to fault point in case of positive sequence, in case of negative sequence, in case of zero sequence. But in case of positive sequence and negative sequence, reference is selected as neutral, but in case of zero sequence reference, is going to be ground. That means when grounding is changed, only zero sequence calculations are changes, but positive and negative sequence reactance calculations going to be same. Am I correct? Let us start right now. He asked fault current in per unit. Tell me how to calculate fault current in per unit for LG fault or line to ground fault. In case of line to ground fault, fault current per unit is 3 times ER1 upon x1 equivalent plus x2 equivalent plus x0 equivalent. This is the fault current expression in case of line to ground fault. Already we completed induced EMF in per unit. How much we got the result? The result for induced EMF is 1.045 per unit, okay. Now dear friends, how to calculate positive sequence reactance, negative sequence reactance, zero sequence reactance? This will be the question right now. See, directly I am going to apply the shortcuts. The positive sequence reactance of the generator is 15%, positive sequence reactance of the transformer is 5%, and positive sequence reactance of the transmission line also 5%. Now look here, how all these three are connected up to the fault point, look like all are in series. Therefore, equivalent positive sequence reactance is 15% plus 5% plus 5% will be 25%. Therefore, Equivalent positive sequence reactance is 25%. Next, negative sequence reactance. How to calculate negative sequence reactance? Direct shortcut. Negative and positive sequence reactance calculations, reference is not ground, neutral is the reference. Therefore, directly we can add without any network, so that it is time wasting if you are going each and every circuit as a network. Negative sequence reactance 12%. In case of generator, in case of transformer 5%, in case of transmission line 5%. 5 plus 5, 10 plus 12 will be 22%. Now tell me, negative sequence reactance also completed. And one thing, dear friends, LV winding connection is given in delta connected manner, HV winding is given star with reactance grounding. Already I have explained why generator is going to be star with reactance grounding. Yesterday only I have explained why LV winding of the transformer is always connected in delta connected manner, already discussed in basic class. Why HV winding is going to be connected in star connected manner with any one grounding. Already everything I have explained in the basics. If anybody not listened, please go through the basics. Why the groundings of the equipments of the synchronous generator or transformer is going to be like this. And the reactance grounding is given at HV, but is not given the reactance value. Therefore, you please select this neutral reactance of the transformer is going to be 5%. Okay. Sandeep is given 3.823 per unit. Sai also given 3.72. Both are slightly different, given difference answer. Let's check anybody who did mistake. Okay. Now let us go to zero sequence calculations. In case of zero sequence calculations, ground is the reference. Now tell me, generator is replaced by reactance with zero sequence reactance. How much zero sequence reactance given? 8%. Next, he given in between neutral and ground is the reactance grounding. Therefore, this is neutral and this is ground. The ground to neutral, neutral to ground, even though he is given xn, we have to write it as 3xn, where xn value is given as 5%. Already I have explained this concept, why you have to take 3xn value but not xn during grounding, right? Next, dear friends, transformer both the windings is going to be represented by 1 per unit reactance, because both the windings will have same per unit reactance in case of per unit representation. There is a transformer zero sequence reactance given 5%. Now this side delta is given. Whenever delta is given, operate the parallel switch. This is the parallel switch. And this side star winding is given. Whenever star winding is given, we have to close the series switch. No need of parallel switch. All these concepts I have explained in case of transformer symmetrical components. Now tell me, what is the grounding is given? Reactance grounding. Therefore, close the series switch with the reactance grounding. But even though the value is given as xn, you should take it as 3xn. Already explained the concept. Therefore, 3 into xn value is 5%. Now, transmission line zero sequence reactance is given as 15%. Therefore, the transmission line is going to be represented by 15% reactance. Wherever fault is occurred, we have to measure the equivalent reactance. The name of the equivalent reactance is called zero sequence driving point reactance. In fault calculations, already I have explained, it is a driving point reactance calculations, but in case of stability, it is going to be transfer reactance calculations. That is the difference between fault analysis and power system stability. Okay. Now X naught equivalent. Tell me, dear friends, whenever this is going to be open, this is not included in the calculations. X naught equivalent will be 5% plus 15. 20% plus 15, 35%. Therefore, zero sequence reactance is 35%. Now, all the values are known. Substitute in the formula, you will get the answer. Tell me, 3 times ER1 value is 1.045. Positive sequence reactance is 25%, which means 0.25. Negative sequence reactance is 22%, means 0.22. Zero sequence reactance, just now we calculated 35%, which is 0.35. Can anybody give this answer? Can anybody give this answer? Already given this answer. Let me check. Three into 1.045 divided by 0.82. 3.823 per unit is the fault current. 3.823 is the correct answer. Sandeep, you given correct answer. Sai Tarkesh is given little bit slightly different answer. You please correct that, Sai, where you did mistake. Okay. This will be the fault current per unit, my dear friends. Anybody have doubts here? If anybody have doubts, please reply in the chat box so that I can understand. Please reply in the chat box so that I can understand. right? Anybody have doubts up to now? Sai Tarkesh, okay sir. Okay, now suppose, dear friends, fault current per unit is completed. Now if anybody is asking how to calculate fault current actual value, can anybody give the answer? How to calculate actual value of fault current? It is going to be calculated as fault current per unit into base current. Am I correct? Fault current per unit multiplied by base current. Fault current per unit is calculated as 3.823. The base current is calculated as S by root 3 VL. Already we discussed all these basics yesterday class. Tell me, question is, what is the power rating? Generator power rating is given as 30 MVA. Am I correct? Now tell me, whatever the power is going to be here, that is 30 MVA, same power is going to be at the transformer, because the power which is entering into the bus bar is always equal to the power which is leaving from the bus bar. That is the reason why power ratings are not specified at bus bar. Very clearly these basics I have explained. Now tell me, generator power rating as 30 MVA, therefore the leaving power from this bus bar also going to be 30 MVA, and the power which is entering into this bus bar is 30 MVA, therefore the power which is leaving after the bus bar also 30 MVA. I can say at the fault point power rating is going to be 30 MVA. Now 3.823 per unit multiplied by power rating. What is the power rating? 30 MVA. 30 into M means mega, mega means 10 power 6 upon root 3. The voltage at the fault point will be selected as a base voltage as and when is not given. What is the voltage at the fault point, dear friends? 33 kV. Therefore root 3 multiplied by 33 into 10 power 3 due to kilo. Now this value is 3.823 multiplied by 30 divided by root 3 multiplied by 33, which is approximately 2 kilo amperes, because it is 10 power 3, this is 10 power 6, will be 10 power 3. 10 power 3 can be written as kilo amperes, right? Nobody is given fault current actual value. Even though he did not ask, you please try. 2.006 kilo amperes will be the correct answer. 2.006 kilo amperes will be the correct answer. Sandeep, you given correct answer. Super. What about remaining friends? Remaining friends are not active. Why they are not giving correct answers? Sorry, why they are not responding in the chat box? Why remaining friends are not responding in the chat box? Now one more question is there. What is the one more question? Voltage of the neutral in per unit. Tell me how to calculate neutral voltage, friends. How to calculate neutral voltage? Neutral voltage is calculated as IN into XN. I already discussed this. Now tell me how to calculate IN. IN is nothing but during line to ground fault, IN is equal to IF, because IN and IF both are equal to 3 times IR0. Already IF is calculated. How much IF? 3.823. 3.823 is the neutral current, neutral current or fault current. Now tell me, at the fault point grounding is given. See, this is the line to ground fault. Engineers, at this fault point, at this line to ground fault, what is the grounding is given? Grounding is given at the HV winding of the transformer. That means this grounding is the reference for case of line to ground fault, because the grounding of this is going to depends on this nearest neutral point. What is the nearest neutral point? This HV winding. What is the grounding reactance is given as XN, that is 5%. That means 0.05 is going to be the XN value. Now anybody can give this answer? 3.823 multiplied by 0.05 will be the neutral voltage per unit. 0.19115 per unit is the neutral voltage. That's it. Still nobody is given the answer. Still nobody is given this answer. Now how to calculate actual value of neutral voltage is equal to per unit neutral voltage multiplied by base voltage. Per unit neutral voltage is 0.19115. The base voltage at the fault point we have to take. What is the base voltage at the fault point? 33 kV, but it is line voltage. Always whenever three-phase system is given, by default the given voltage is line voltage, but base voltage how to calculate for star connected network? Line voltage by root 3, that is 33 kilovolts divided by root 3. Now multiplied by 33 divided by root 3. Answer is 3.64. 3.64 kilovolts is the neutral voltage of actual value. Actually, I am calculating all the answers, dear friends. Sandeep is given correct answer, Lalit is given correct answer. I think I am forward in today compared to remaining friends. Remaining friends are like, today you are slow, I am very fast, so that I am getting all the solutions. Now tell me, how to calculate short circuit power? Short circuit power or short circuit MVA or breaking capacity, all the formulas are same. It will be calculated as MVA base multiplied by IF per unit. Now tell me, MVA base is how much at the fault point? 30 MVA, and fault current we calculated as 3.823 per unit. Therefore, the short circuit MVA is going to be 3.823 multiplied by 30. Answer is 114.69 MVA is the breaking capacity of the circuit breaker. Already explained, circuit breaker is designed to withstand maximum breaking capacity. Therefore, the circuit breaker has to withstand this much of short circuit power. Am I correct? Even though the rating is going to be 30 MVA, circuit breaker is designed with respect to maximum withstanding capacity. That maximum withstanding capacity right now is 114.69 MVA. That means the rating of the synchronous generator, even though given 30 MVA, therefore the breaker which is connected to the synchronous generator, the circuit breaker which is protecting the synchronous generator also having 30 MVA base power, but even though due to occurrence of short circuit fault the breaking capacity increased to 114.69, the breaker also going to be withstand that much amount of power. That's the reason why the fault is going to be not damaging our power system. This is the most important point that everybody has to understand. Okay, this was the solutions for all the questions. Now my question is, I have a beautiful question. Can I ask the question? Can I ask the question? The question is, instead of reactance grounding here, he assumed it is a solid grounding. Assumption it is a solid grounding. Can anybody give fault current per unit? Same answer. That is not same answer. Reason, see, fault current per unit will be changed. Reason, zero sequence reactance is changed. Reason, it is solidly grounding. Whenever it is solidly grounding, this value will become 0. Therefore, zero sequence reactance is not 35%, it will be 20%. That means whenever solidly ground is given, positive sequence calculation is same, negative sequence calculation is same, zero sequence reactance will become right now 20% due to solid grounding. Now substitute that value here and tell me what is the fault current here, right? Fault current per unit is going to be 0.20 per unit because of solidly grounded. And what is this answer? May I know please? 3 into 1.045 divided by 0.45 plus 0.22 will be 0.67. Answer is 4.67 per unit. Now see, whenever grounding is changed, fault current also changes in case of line to ground fault. Therefore, dear friends, L2 line to ground fault, LG fault is always compulsory required grounding. Now, can anybody give the answer? What is the neutral potential right now? Anybody? Neutral potential is going to be how much? Please give the answer in case of it is solid grounding at the time at the occurrence of the line to ground fault. Anybody can give the answer? Anybody can give the answer? Lalit Mahawar is given, Srinath is given, Sandeep is given, 4.67 per unit is the fault current. Very good. Lalit is given, answer is 0 per unit. Excellent. I am appreciating Lalit. The reason neutral potential right now is going to be 0. Why? Because at the fault point is given grounding as solid grounding. Whenever it is solid grounding, reactance of solid grounding is 0. Irrespective of the neutral current or fault current, neutral potential will become 0. Sandeep also given 0. Super. Sandeep and Lalit, both are superb. Both given 0 answers, right? Perfect answers. Reason, at the fault point is given grounding as solidly grounding. Whenever it is solidly grounding, definitely due to solid grounding, impedance will be 0, reactance is 0. When reactance is 0, neutral potential also 0. This will be the correct answers. You try to please remember these concepts. Whenever grounding is changes, what will happen? Be alert at the time of solving the questions. Am I correct? Am I correct? Let us move to another question. This will be the excellent question. Please try to solve this question. Please try to solve this question. Another question. Another question is there on the screen. You please try to solve this question. You please try to solve this question. Please give the answer for this question. Anybody can give the answer? Please give the answers, dear friends. This will be the question. Anybody? Time limit is only 1.5 minutes, means 90 seconds. Yeah, question is already there on the screen. Therefore, please try to give the answer. Question is really very simple question. Yeah, this will be the question. Nobody replied the answer. What happened, my dear friends? What happened? Please give the answer. Please give the answer. Waiting for your answer. Waiting for your answer. Really excellent question. Okay, I will start right now because you become delayed. He given alternator rated as 11 kV 20 MV. As and when you read the data, please draw the alternator immediately. This is the simulation diagram of a synchronous generator. This synchronous generator or alternator is given rated voltage as 11 kV and the power rating of the alternator is 20 MVA. That's it. Next, having a sequence reactances, he given sequence reactances XD double dash is 12%, means XD double dash means positive sequence subtransient reactance of the generator, and X2 means negative sequence reactance of the generator also given as 10%, and zero sequence reactance of the generator is given as 5%. Very good. And he said positive sequence given, negative sequence given, zero sequence given. What he said is calculate the neutral reactance in ohms. That means the generator is going to be reactance grounding. This is going to be reactance grounding. He said calculate this Xn value in ohms. He is asking this Xn value to calculate in ohms. Ohms means actual value or per unit value? Actual value. Okay. Calculate the reactance in ohms to be inserted to limit the fault current equal to rated current of the alternator. That means the fault current in the alternator is equal to rated current of the alternator. But which fault is did not mention. Whenever it is not mentioned, let us assume any one fault. Right now LG fault discussion is going. Let us assume that fault is line to ground fault. Okay. Which fault? Line to ground fault. Now tell me dear friends, what was the concept here is, he said calculate the neutral reactance in ohms which is placed in the neutral grounding so that the fault current is equal to rated current of the alternator. Tell me, fault current is equal to rated current of the alternator. Rated current of alternator is in actually amperes, therefore fault current actual value is equal to rated current means base current. Am I correct? Now fault current per unit, how to calculate per unit current? Actual value of current, that is a fault current, upon base current or rated current. Whenever he said these two values are equal, then fault current per unit is equal to 1. This will be the first step. Now we know that dear friends, fault current formula in case of line to ground fault is 3 times ER1 upon x1 equivalent plus x2 equivalent plus x0 equivalent. But question is, he said that the voltage at the synchronous generator is 11 kV, therefore fault also occurred at the synchronous generator, therefore this will be the actual voltage and base voltage is not given. There is only one machine. If base value is not given, select same generator ratings are the base values, therefore this generator voltage itself will be selected as base voltage. Now positive sequence induced EMF in per unit is equal to, how to calculate per unit voltage? Actual voltage divided by base voltage. Tell me dear friends, what is the actual voltage? 11 kV. Whenever base voltage is not given, I already explained per unit basics, select same machine ratings will be selected as base, then we can calculate the per unit values. Therefore ER1 is 1 per unit. Already we calculated fault current per unit is equal to 1 per unit is equal to 3 times of ER1 is 1 upon x1 equivalent is given, positive sequence reactance how much? 0.12 plus negative sequence reactance is given how much dear friends? 0.1 and 0 sequence reactance. How to calculate 0 sequence reactance? Anybody? 0 sequence reactance is going to be including grounding effect, that is Xg0 plus 3Xn. Now tell me, here Xg0 is given as 5%, which means 0.05 plus it should be 3Xn or Xn? 3Xn. Now all these values are per unit values, therefore calculated reactance also will be in per unit. Now tell me how much this value? 0.22 plus 0.05 will be 0.27 plus 3xn is equal to 3. From this, what is xn value? Anybody? 3 minus 0.27 divided by 3. Xn value is going to be 0.91, which is in per unit or actual value? Per unit. Why? Because we have discussed so far per unit calculations. Am I correct? Now Vyasri given 3.493. Oh, she deleted once again. Sandeep is given 0.91. It is the per unit, Sandeep. But question is, that's why I said always, writing gate exam is really a kind of art. Art means, you know, ART art. Writing exam is also kind of art. But before writing the exam, already yesterday I told, according to famous scientist Albert Einstein, you have to read the question very properly. If you understand the question properly, 50% is solution is available there itself. Remaining 50% you can complete by using our knowledge, right? All people are given 0.91. You are perfectly wrong. Why? Because he did not ask per unit reactance. He asked calculate the reactance, neutral reactance in ohms. That means once again you are doing mistakes. This is going to be most dangerous thing. That means you are not reading the question properly. That is the problem with you right now. He given per unit we calculated per unit reactance. Then how to calculate reactance in ohms? That means we have to apply per unit concepts, ohms to per unit formula. Xn per unit is equal to, what is the formula? Xn, neutral reactance in ohms, multiplied by MVA base upon kV base square. This already we discussed in case of per unit calculations. Neutral reactance in per unit is 0.91 we calculated. Neutral reactance in ohms is unknown. Already I said, my dear friends, when there is only one machine, if base value is not given, select same generator rating or same that machine ratings will be as base values, then we can go per unit calculations. Now tell me, what is the base power? 20 MVA and voltage will be 11 kilo square, right? From this, neutral reactance in ohms is equal to 0.91 multiplied by 11 square divided by 20. This will give correct answer. Now let me discuss right now. Point 91 multiplied by 11 square divided by 20 will be 5.05 ohms is the correct answer. That means we have to place 5.05 ohms in the neutral grounding as the reactance value, so that the fault current per unit is equal to rated current of the alternator. Right now Lalit also given correct answer, Sandeep is given correct answer, 5.50 ohms. Tell me all my dear friends, you need to solve this kind of questions or a very simple questions? Please reply in the chat box. You need to solve this kind of good questions or a simple questions? Please reply in the chat box. Very good. Sandeep and Lalit is given perfect answers. Congratulations both of you. What about remaining friends? Are you there? Remaining dear friends, are you there? Srinath also given, super. Srinath, congratulations, 5.50, 55 will be the correct answer. But you did not mention units of units, Srinath. Srinath, it should be per unit or units. Sandeep Saha, Brock Lesnar type question, sir. Oh my god. Sai Tarkesh, 5.46. Why Sai Tarkesh is giving answers very close to the correct answers? Where Sai is doing mistakes, I need to know, because I want to correct his mistakes. That's why. Sai, previously also you given answer very close to actual answer, but right now also you given 5.46, but it is 5.05. 5.50. I did mistake. Sorry. Now 5.46 Sai got the answer, and I got the answer 5.50, remaining also got 5.50. Then where Sai is doing, that means Sai is coming very close to our answers. Where he is doing mistakes? I think he is not taking all the digits after the point. That's why he is committing that, he is getting that approximate results. You have to use all the points what you are getting, so that it will be easily understood by you. Okay, this was the question. I think everybody clear about this? By mistakes are one step. Okay, Lalit, there may be error in calculator. Oh my god, if it is error, answer will not come, Lalit. Okay, let us move to another question. Time is wasting here. This was the question. This was the question. Please try to solve this question. Let me copy this question to the screen. Yeah, please give me the answers. Please give me answers, my dear friends. Dear friends, please give me the answer for this question. Question is there on the screen. Question is there on the screen. Alternator having a reactances, he given positive sequence reactance. First let us draw the alternator. This is the synchronous generator. The synchronous generator have positive sequence reactance. How much? 15%. XD double dash is given positive sequence subtransient reactance 15%, negative sequence reactance 15%, and zero sequence reactance how much is given? 5%. Already we discussed, dear friends, in case of synchronous generator, positive sequence, negative sequence reactances are equal. Zero sequence reactance is less than positive sequence reactance in case of synchronous generator. Already I have explained all these things. Now he given neutral reactance. How much is given neutral reactance? 5%. That means the generator is going to be reactance grounding, that is Xn is equal to 5%. And he given voltage rating and power rating of the generator, that is 13.2 kV as well as 60 MV. These are the power ratings. Okay. Now question is super question. The positive sequence subtransient current of LG fault of the alternator is, that means he said it is a LG fault occurred on the generator. He said LG fault is occurred on the generator. Am I correct? Now what is the point he is saying? Positive sequence subtransient current. He given very good question really. It is a powerful question. He did not given fault current. He given positive sequence current of the LG fault is 2 per unit. That means IR1 is given as 2 per unit. Then he is asking what is the magnitude of neutral voltage. But tell me how to calculate neutral voltage, dear friends. Neutral voltage Vn is calculated as In into Xn, where in case of line to ground fault In is also same as If, because In equal to 3 times IR0, If also 3 times IR0. Now positive sequence current is given, then how to calculate fault current in case of line to ground fault? 3 times IR1, 3 times of IR1 value is 2, 3 into 2 which is 6 per unit. Now this is going to be 6 per unit, and neutral reactance is given how much, my dear friends? 0.05, which is 0.3 per unit. This will be the not final answer. Why? Because he is asking neutral voltage in volts. Am I correct? What is asking? Neutral voltage in volts means actual voltage. Actual voltage is equal to per unit voltage multiplied by base voltage, that is 0.3 base voltage. What is the rated voltage of the generator? 13.2 kV. Whenever base voltage is not given, select that same voltage will be as the base voltage, 13.2 kV divided by root 3. That means the base voltage always calculated as line voltage by root 3. Anybody can give this answer? 13.22 divided by root 3. Answer is 7.62 kilovolts is the neutral voltage in kilovolts. Srinath is given 3.96 kilovolts. Sandeep is given 3.96 kilovolts. Oh, I understand your point right now. Why you did mistake? Srinath and Sandeep, both are given wrong answers. Both are given perfectly wrong answers. Navyasri also once again trapped in my trap. All are trapping. I am really trapping all of you. You did very good mistakes really. Tell me, dear friends, how you will correct these mistakes? He said positive sequence current. He did not said fault current, but you taken this as a fault current. Once again mistake is going on. Already said yesterday. Many times I repeated this. Once again you are doing. Srinath is given 2.286 kilovolts. Yes sir, line voltage. Srinath once again changed the answer, 2.286. See, he given, I think all of you did mistake here. You taken this as a fault current. Fault current is, it is not the fault current. It is given positive sequence subtransient current. Positive sequence subtransient current is 2 per unit. Sorry. You are correct. I am wrong. Dear friends, I am wrong. Why? Because positive sequence subtransient current nothing but positive sequence steady state current means fault current. Positive sequence subtransient current means it is going to be first cycle current, that is fault current. Sorry, I taken IR1 as 2 per unit. It is not IR1, it is IF only. Sorry. Positive sequence subtransient current means fault current only, which is 6 per unit, 2 per unit he given. Now substitute, it is 2 into 0.05. 2 into 0.05. 2 into 0.05, which is 0.1 per unit. And he asked actual voltage. This is 0.1. 0.1 multiplied by 13.2 divided by root 3. It is 0.762. 0.762 kilovolts is the correct answer. Nobody is given this answer. Sandeep Saha, sir, question given positive sequence subtransient current. See, if he said positive sequence current, that you have to select it as IR1, but he said positive sequence subtransient current. What is the meaning of positive sequence subtransient current? Satish is given correct answer, 762 volts or 0.762 kilovolts, right? Both are the correct answer. Satish is given correct answer. I will explain, dear friends. He did not given positive sequence current. He given positive sequence subtransient current. That is a twist here. Positive sequence subtransient current means it is a current which is flowing during first cycle of operation. I said during first cycle of operation the current which is flowing is called as positive sequence subtransient current. The positive sequence if it is given positive sequence current, then we can take it as IR1. But he given positive sequence subtransient current means positive sequence subtransient current is always the current which is flowing through the first cycle of operation. Therefore, the given current is nothing but fault current only. I am also sorry, I also confused, but anyhow I corrected the answer. Satish got the correct answer, 762 volts or 0.762 kilovolts. Both are the correct answers. I think everybody clear? Have any doubts? Have any doubts? Now tell me, line to ground fault is compulsory, grounding is necessary or not necessary? Necessary. When grounding it changes, definitely what will happen? When grounding it changes, definitely what will happen? Reactance calculations are also changes. This will be the question. Let us solve this question. Everybody. Sandeep, now clear. Very simple question I given, my dear friends. Can anybody give the answer? Can anybody give this answer? Can anybody give this answer? Lalit Mahawar, from first cycle there is no zero or negative. Lalit, really you are confusing about the symmetrical component concept. First cycle, see, the first cycle current is called as positive sequence subtransient current, that will be taken as reference during fault calculations. Means along with, see, in order to understand the unbalanced current, we are using that symmetrical component, that is positive sequence, negative sequence and zero sequence, right? Okay, now what will be the answer? Satish, LLG sir. Oh my god, this is not related to LG fault. I thought this is related to LG fault. The following currents are recorded in power system under a fault condition. IR1 equal to J1.653 and negative sequence current is given minus J0.5, zero sequence current is given minus J1.153. Now if you add all these currents, sum of these three sequence currents are equal, sum of these three sequence currents are equal to 0, then the fault is line to ground fault. This is still not discussed. I thought this is given in terms of voltage. Instead of current, if we given voltage like VR1 is equal to J1.653 and VR2 equal to minus J0.5 and VR0 is equal to minus J1.153. I thought the given question, the following currents, instead of currents if we given voltage, are recorded in power system under a fault condition. Now tell me, sum of the sequence voltage is going to be 0. When sum of the sequence voltage is going to be 0, that fault is going to be line to ground fault. Yesterday already we discussed. Now sum of the sequence currents is 0, that is line to ground fault. Sum of the sequence voltage 0, that is going to be line to ground fault. Yesterday already we discussed about this. This we will discuss in line to ground fault. Okay. I think everybody understood, my dear friends. Satish, you change the answer. Okay, for this question you given the answer, right? But all sequence current not same, sir. In case of line to ground fault, Sandeep, all the sequence, sum of the sequence currents are equal to 0 and all sequence voltages are equal. This is not yet discussed, but unfortunately I taken question of line to ground fault. That's why I have given answer for this question, but this I will discuss tomorrow in line to ground fault. But instead of current, if we given voltage ratings, then some of the voltage will be equal to 0, then the fault is line to ground fault. That means it is only voltage rating. That means in case of line to ground fault, all sequence currents are equal and some of the sequence voltages are 0. Actually this question answer is line to ground fault. Instead of this currents, if I taken voltage ratings, then some of the voltage will become 0, then it will be line to ground fault. That I am explaining, Sandeep. I think everybody got the concept. Now let us move to line fault today. I am going to start line to line fault. Any newcomers are there? Please join right now with me. Line to line fault. I am going to start the discussion. LL fault or line to line fault. I am ready. Are you ready? Already we discussed, dear friends, faults are more common on transmission line, but analysis of the fault on the synchronous generator. Why? Because stator winding of the synchronous generator is a 3-phase star connected manner, and transmission line also going to be 3-phase star connected. Therefore, if you are analyzing fault on the synchronous generator stator winding, is equal to same analysis on the fault on the transmission line. That already we discussed. Therefore, right now I am going to start line to line fault or double L fault. This is the rotor field winding. Rotor field winding is separately excited by DC supply. That's why synchronous generator is called as double excited machine, but induction generator is going to be single excited machine, and stator winding is going to be star connected winding. We know all these concepts. During short circuit fault, inductance is dominant. Therefore, the stator winding I am representing only by inductance, that is inductive reactance, but not resistance, because resistance is negligible due to large area of cross section of the windings. And the in between neutral to ground, I represented the reactance grounding. Am I correct? Now dear friends, induced EMF in the stator winding is going to due to clockwise fluxes, that is rotor flux, but not due to negative sequence or zero sequence. Am I correct? All these things will be discussed already. And this is going to be assumed R phase, this is assumed as Y phase, this is assumed as B phase. Tell me, before occurrence of the fault, always we have to assume that the synchronous generator is under no load operation, right? Before occurrence of the fault, we have to assume the synchronous generator is under no load operation. What is the meaning of no load operation? The current flowing through each phase is assumed to be 0 under no load condition. This will be the reference in order to analyze any fault in power system. That means before occurrence of the fault on the stator winding of synchronous generator, we have to assume synchronous generator is under no load operation. Under no load operation, as load is disconnected from the source, therefore the current in all the phases will be assumed 0, and the voltage of all the phases is going to be RMS voltage. Now tell me, voltage of R phase, Y phase, B phase is VR, VY, VB, nothing but RMS voltage. Now tell me dear friends, what was the concept here? The magnitude of voltage in all three phases are equal, and the current flowing through all the three phases also equal. The system is under balance condition, right? This will be the reference condition in order to start the power system right now. Okay, let us assume suddenly there is a short circuit fault occurred between any two phases. That means any of two phases got short circuit. Whenever any two phases get short circuit, let I am assuming Y and B phase is going to be short circuited like this. Whenever Y and B phase is going to be short circuited like this with a solid fault, due to solid nature here, the magnitude of fault current is more severe than fault impedance. First I will explain. First with solid fault, later I will explain with some fault impedance what will be the calculations that we will observe. Don't worry about that. Okay. Whenever line to line there is a short circuit, then the current easily flowing from this surface of the conductor to this surface of the conductor, so that current in the Y phase and B phase will not equal to 0. Current in the Y phase and B phase will not equal to 0 because of short circuit. Now tell me, how much current which is flowing through the short circuit is going to be fault current. fault current in these two phases is going to be more than RMS current, because already we studied in case of transmission line, the fault current is carrying two currents. One is AC component of current, other is going to be DC offset current. Therefore, the fault current is combination of AC plus DC offset current. Now tell me, the Y phase and B phase both will become short circuit. Therefore, current is enjoying between these two phases by touching from one surface to another surface. The current in these two phases is going to be more than RMS, but still R phase is healthy phase. Whenever R phase is healthy phase, current in the healthy phase is going to be 0, but current in these two phases are not equal to 0. Now tell me, all magnitude of currents in the three phases are unequal. System is unbalanced. When system is unbalanced, how to solve unbalanced electrical quantities? By using symmetrical components. Very clearly explained. How to solve unbalanced electrical quantities? By using symmetrical components. And one more thing, dear friends, due to R phase is healthy phase, voltage in the R phase is going to be RMS voltage, but Y phase voltage, B phase voltage, due to short circuit, it is not RMS voltage. Tell me, whenever short circuit is occurred, voltage of Y phase, voltage of B phase is going to be reduced, but not equal to 0. Reason, whenever this fault is shorted and then grounded, due to ground we can say voltage of Y phase and B phase equal to 0, but there is no ground here, only there is a short circuit between these two phases. Because of that, the voltage of these two phases will be less than RMS voltage but not equal to 0. When those voltage will become 0? When there will be a ground along with the short circuit, we can assume that will be 0 voltage. Reason, in the ground impedance will become 0, automatically voltage also 0. As this fault is shorted between two phases but not grounded, as and when that is not grounded, automatically voltage of those two phases will get reduced less than RMS voltage but not equal to 0. I think dosto means, dear friends, have you got my concepts? Now let me analyze right now. See, current in the R phase is 0. Current in the Y phase, IF is equal to, see, the direction of Y phase current and fault current is same. IF is equal to IY, but this current is opposite to IB, that means which is equal to minus IB. Which is equal to minus IB. These are the currents in the three phases. Now voltage in R phase is RMS voltage. Voltage in Y phase, voltage in B phase, both are less than RMS voltage. Less than RMS voltage but not equal to 0. Why these two voltages are not equal to 0? Reason, even though there is a short circuit but both are not connected to ground, that's why it will not become 0 but voltage will be less than RMS voltage. Okay. Now tell me, dear friends, the magnitude of voltage in Y phase, voltage in B phase is less than RMS, but voltage of R phase is equal to RMS voltage. Therefore, all three voltages are unequal in magnitude. All three currents are unequal in magnitude. System is unbalanced. How to solve unbalanced electrical quantities? By using symmetrical components. Now tell me, symmetrical components that we can use right now in terms of current vectors or voltage vectors. Tell me fastly. Tell me fastly, we have to use symmetrical components in terms of current vectors or voltage vectors. Reply in the chat box, my dear friends. Nobody replying the answers. Nobody replied the answers. I given the question. System is unbalanced, we have to use symmetrical components. You have to tell me right now, we have to use symmetrical components in terms of current vectors or voltage vectors. We can use any of them, but which is going to be simple? Lakshmi is given current, Lalit is given current, Navyasri given current, Shiva is given voltage vector, Sandeep is given current, Srinath is given voltage, and Srinath and Shiva both are given voltage vectors. Remaining all are given current vector. Sai also given voltage vector. Why? Sai, Sandeep and Sai, Shiva as well as one more friend is given voltage, Srinath. These three people are given voltage vectors. Now let us concentrate here. If I use voltage vectors, tell me, dear friends, I am saying voltage of R phase is equal to RMS voltage, but how much magnitude? We don't know. This magnitude is unknown, but we are saying RMS voltage, but we don't know what is this magnitude of. And these two we are saying these are less than RMS voltage, but how much magnitude exactly we don't know. Therefore, there will be three unknown parameters if you take in voltage side. But if we take current side, exactly we know the current in R phase is 0. That means at least one phase current is known, but we don't know all exactly what is the magnitude of all these three phase voltage. Therefore, if you take voltage vectors in case of symmetrical components, calculation time is going to be more complex. Sorry, calculations will be more complex. Therefore, evaluation time also increases. In order to go for smooth calculations, the known vector is going to be present in the current side more. At least R phase current is known, so that if you use current vectors in the symmetrical components, analysis will become simple. That's the reason why I am going to use current vectors as the symmetrical components. Now tell me, zero sequence current IR0 equal to 1 by 3 IR plus IY plus IB. Dear friends, my question is, what is the current in R phase? Current in R phase is 0. Now 1 by 3, 0, IY is equal to IF. Y phase current is equal to fault current. B phase current is equal to negative sign of fault current. Therefore, these two cancel out. Now tell me, zero sequence component is not present in case of line to line fault. Very, very important. Yesterday fault we discussed line to ground fault. In line to ground fault we have zero sequence component, but in case of line to line fault there is no zero sequence component. Why? Because this fault is unbalanced fault without any ground. Whenever there is no ground, no need to represent grounding effect, therefore no need of zero sequence component. Therefore verification is successfully completed. Now tell me, in case of line to line fault, the fault is even though unbalanced, it is not grounded, therefore there is no need to represent grounding effect. Whenever there is no need to represent grounding effect, zero sequence also not necessary. Now our mathematics and physics both are tallying, because matching. That means zero sequence current is going to be, zero sequence component is going to be absent in case of line to line fault. Okay. Now positive sequence current IR1 is equal to 1 by 3 IR plus K times IY plus K square times IB. Okay. Now already, dear friends, R phase current is 0. Now positive sequence current IR1 can be written as 1 by 3 K times IY. Now we know IB is equal to minus IY. Just now we discussed IB is equal to minus IY. Therefore, in place of IB we are writing minus IY. Now tell me, positive sequence current IR1 is equal to, let take IY common, IY by 3 K minus K square. You know friends, K minus K square is not equal to 0. Therefore, positive sequence current is not equal to 0. That means positive sequence component exists. Why positive sequence component exists? Reason, either in balanced condition or unbalanced condition, always positive sequence component is present. That's the reason why positive sequence component exists in the case of line to line fault, because it is unbalanced fault. And negative sequence current IR2 equal to 1 by 3 IR plus K square times IY plus K times IB. Already R phase current is 0. Therefore, negative sequence current IR2 equal to 1 by 3 K square IY I am writing as it is, IB equal to minus IY, therefore minus K IY. Now tell me, IR2 is equal to, take minus IY common right now, minus IY by 3. Whenever you take minus IY common, it should be written as K minus K square. Already K minus K square is not equal to 0, therefore negative sequence current also not equal to 0. Now tell me, in case of line to line fault, we have positive sequence component as well as negative sequence component. There is no zero sequence component, because line to line fault is unbalanced fault without any ground. During unbalanced condition without any ground, we have only positive sequence component as well as negative sequence component. There is no zero sequence component. This is the most important point. Now question is, K minus K square value. What is the value of K? Can anybody give the shortcut answer? K. Can anybody give the shortcut answer? I given these answers already. Can anybody give the shortcut answer for K and K square? Please reply in the chat box, my dear friends. What is the value of K? Shortcut already given in case of symmetrical components. What is the value of K? Minus 0.5 plus J 0.867. And K square value is minus 0.5 minus J 0.867. I said there, how to remember. This question is commonly asking either central government or state government or IAS objective. Dear friends, how to remember this? K and K square both are having same real part and same imaginary part. What is the real part? 0.5. What is imaginary part? 0.867. That means value of K, K square both have same real part, same imaginary part, and k power 1, as power is 1, therefore only one negative sign in k value, and k square power is 2, therefore both are the negative signs. In this way I have given the shortcut already, but nobody replied the answer right now. Srinath is given 1 at an angle 120 degrees. Okay, that is in case of polar form, but in rectangular form minus 0.5 plus j 0.867. Super, Srinath is given correct answer. Nice reply. Now tell me how to calculate k minus k square. It is going to be minus k square is equal to, it is plus, means both are cancelling, it is plus. Now tell me how much this value, j 1.732. Whenever this value is j 1.732, therefore this entire value is not equal to 0. I can say line to line fault is unbalanced fault. I am writing here note. The note is line to line fault, first unbalanced fault, line to line fault is unbalanced fault without grounding, this is the first result. Second result, therefore positive and negative sequence components, positive and negative sequence components are present, but no zero sequence component. This is going to be most important points that everybody has to remember during line to line fault. Okay, this will be the points that everybody has to remember. Line to line fault is unbalanced fault without grounding, therefore there is no necessity of zero sequence component. We have only positive and negative sequence component in line to line fault, and there is no zero sequence component. Now it is clear, my dear friends, how to calculate positive sequence current. That is the concept right now. Tell me where fault is occurred. Fault is occurred in y and b phase, therefore we need to analyze the fault with respect to y and b phase, but not r phase. Why? Because r phase is healthy phase, y and b phase both are fault phases, therefore we have to analyze the fault current with respect to y phase and b phase. Now tell me what is the fault current. IF is equal to IY, which is equal to minus IB. That means the y phase current and fault current both are in same direction, but both are opposite to b phase current, therefore minus IB. Then you take fault current, you can take either IB, IY or minus IB. No need to take both. Okay, let us concentrate right now. IF is equal to IY. Now tell me, current in all the phases are unequal, therefore replace that y phase current by symmetrical components, that is IY0 plus IY1 plus IY2. But zero sequence component is going to be 0 in case of LL fault, because LL fault is unbalanced without ground, therefore there is no zero sequence. Now tell me how to write in terms of R phase. In case of positive sequence component, what is the phase sequence? RYB. That means R2Y, what is the angle? K square, therefore it is written as K square IR1. And what is IY2? Negative sequence component. Negative sequence phase sequence is RBY. R2Y angle is K, therefore it is K times IR2. This is the fault current, but we need to write this fault current in terms of positive sequence current. Am I correct, my dear friends? We have to write this fault current in terms of positive sequence current. But one thing we have to tell here, dear friends, what is that is, tell me, that is the analysis of the current in Y phase and B phase, because fault is occurred in Y and B phase, therefore we need to analyze the current and voltage with respect to these two phases. Now tell me, we have analyzed so far current, now we have to analyze voltage of these two phases. Now tell me, voltage of these two phases are equal because of short circuit. Because of short circuit, voltage of Y phase, voltage of B phase both are equal but not equal to R phase, therefore unequal. Use unbalanced, that is unbalanced components, use symmetrical components. Vy0 plus Vy1 plus Vy2 is equal to Vb0 plus Vb1 plus Vb2. I have used symmetrical components, reason magnitude of voltage in all the three phases are unequal. Now tell me friends, there is no zero sequence components. Vy1 is equal to K square times Vr1. I am reducing number of symmetrical components by replacing Y and B phase components in terms of R phase. Vy2 can be written as K times Vr2. Vy2 can be written as K times Vr2. What about Vb1? K times Vr1. Vb2 is K square times Vr2. Am I correct, my dear friends? Rearrange the equation. When you are rearranging this equation, VR1 take common, it will be k square. This is coming this side will be minus k. VR2, arrange this in the proper manner. This will be k square. If you take this k VR2 that side, it will become minus k VR2. Minus k square minus k square minus k cancelled. Now, positive sequence voltage and negative sequence voltage both are equal in case of line to line fault. Tell me, in case of LG fault, all sequence currents are equal, but in case of line to line fault, all sequence voltages are equal, but there is no zero sequence component. Means in case of LL fault, positive sequence voltage is equal to negative sequence voltage. This is very important point, please remember this. Now tell me, what is VR1? VR1 is nothing but positive sequence terminal voltage of the generator. What is that value? ER1 minus IR1 X1 equivalent. VR2 is minus IR2 X2 equivalent. VR2 is equal to minus IR2 X2 equivalent. But right now I have explained one thing, dear friends. What is that is, observe here. If you observe here, IR1 is equal to IY by 3 K minus K square. IR2 also IY by 3 K minus K square. That means this IR2 can be written as minus of IR1. Why? Because IY by 3 K minus K square is equal to IR1. Therefore, IR2 is equal to minus IR1. See, these two currents are equal in magnitude, but minus sign is explaining that both are in opposite direction. Please remember this concept. Am I correct? Now I am going to use that concept here. So from this, ER1 is equal to IR1 X1 equivalent minus IR2 X2 equivalent. Already I have explained one concept yesterday, that in all the kinds of faults, positive sequence definitely present. Therefore, we need to write positive sequence current expression in each and every fault. In order to write positive sequence current expression in each and every fault, what we have to do right now? Negative sequence current is going to be replaced by positive sequence current, because I am going to write positive sequence current expression. You tell me, minus IR2 is equal to VR1 is equal to VR2, one expression we got. Another expression is IR1 is equal to minus IR2. Therefore, in place of minus IR2, I written it as IR1. From this, IR1 common, it will be X1 plus X2 equivalent is equal to induced EMF, right? ER1 is equal to IR1 plus X1, IR1 multiplied by X1 plus X2. From this, positive sequence current is equal to ER1 by X1 plus X2. This is most important. This is the current. Which current? Positive sequence current of line to line fault. Very, very important, dear friends. See, I will explain one concept here. In LG fault, shortcuts I am explaining. Positive sequence exists, negative sequence exists, zero sequence exists in case of line to ground fault. How to calculate positive sequence current? Current means voltage by reactance. How many reactants here? 3 reactances. Positive sequence, negative sequence and zero sequence. This will be the shortcut already explained in case of line to ground fault. But in line to line fault, we have only positive sequence, negative sequence. Therefore, current will in line to line fault, positive sequence current will be voltage induced EMF by only these two reactants, positive and negative. This is the way you have to remember the shortcuts. Tell me, dear friends, everybody understand the concept? Sandeep Saha, yes sir. Everybody understood the concept? Now I am writing final results. In case of LL fault, the first result is no zero sequence component, positive sequence voltage is equal to negative sequence voltage, positive sequence current equal to negative sign of negative sequence current. Result number 3, positive sequence current is equal to ER1 upon X1 plus X2 equivalent. But one thing is pending. What is that pending? Fault current expression. Fault current already we have written. Fault current is IF is equal to K square IR1 plus K IR2. I can use this formula here. Okay. fault current IF is equal to K square IR1 plus K times IR2, where IR2 we can write it as minus IR1, right? Already we know this. Therefore, fault current we are writing in terms of positive sequence current. What is the common? IR1. It is equal to K square minus K. Just now we discussed K square minus K is equal to minus J root 3 times IR1. But what is the magnitude of minus J root 3? Will be root 3. That means the fault current in case of line to line fault is root 3 times of positive sequence current. In case of line to ground fault, what is the fault current? 3 times IR1. Yesterday we discussed. And today LL fault current expression in terms of positive sequence current is root 3 times of IR1. Now tell me, everybody, have you understand the concepts? So fourth result, fault current in case of line to line fault is root 3 times IR1. Now fifth result, fault current IF is equal to root 3 times ER1 upon X1 plus X2 equivalent. So this will be the final expression. Now tell me, everybody understood the line to line fault calculations? In line to line fault, as it is unbalanced fault, we have positive and negative sequence, there is no zero sequence, okay? Yesterday I have explained line to ground fault. I am going to summarize line to ground fault so that you can understand the difference between LG fault and LL fault, okay? In case of line to ground fault, it is unbalanced with ground, we have positive, negative and zero sequence components, and the first result will be, what is the first result in line to ground fault? All sequence currents are equal. IR1 is equal to IR2 equal to IR0 equal to IF by 3. This is going to be line to ground fault I am discussing. L2 line to line fault already written the results. Second result, sum of the sequence voltages are equal to 0. In case of which fault? Line to ground fault, along with all sequence currents are equal. Third one, positive sequence current, as 3 components are exist, therefore positive sequence current is ER1 upon X1 plus X2 plus X0 equivalent. This is the most important. Now fourth one, fault current in case of line to ground fault is 3 times of IR1. This will be the basic difference between line to ground fault as well as line to line fault. Everybody understood the concepts? Navyasri, yes sir. Shiva, yes sir. Srinath, yes sir. Crystal clear. Sai, yes sir. Lalit, understood. Tell me, dear friends, please reply in the chat box. Everybody understood the line to ground fault as well as line to line fault? Reply answers. Reply the answers. Everybody understood? Shiva, yes sir. This will be the basic difference between line to ground fault and line to line fault. And in case of line to ground fault, as it is unbalanced with ground, zero sequence also exists. Along with positive, negative, LL fault is unbalanced, we are not grounding, therefore only positive sequence, negative sequence exists. Okay. Now question is, let us assume synchronous generator is given, there is a line to line fault, and this generator is given as reactance grounding. Okay. So even it is given reactance grounding, or even it is given solidly grounding, even it is giving resistance grounding, tell me, line to line fault calculations currents will be changed or not? No changes. Why? Because the fault current in case of line to line fault is root 3 times of ER1 upon X1 plus X2. That means we don't require grounding in case of line to line fault. Even it is given reactance grounding, solidly grounding, resistance grounding, isolated grounding, there is no change in fault current calculations in case of line to line fault. Why? Because line to line fault does not depends on zero sequence. This is very important. Now tell me, line to ground fault, zero sequence definitely present, therefore when grounding is changes, line to ground fault calculations are changes. But in case of line to line fault, there is no zero sequence component, even though grounding is changes, there is no change in fault current calculations in case of line to line fault. Now tell me, LL fault, grounding is necessary or not necessary? Reply in the answers. Very good. Lalit Mohavar, no change. Srinath, no effect on grounding. Super, correct answer. Satish, sir, in LG fault, zero sequence reactance, whether containing neutral reactance or not in positive sequence current. Positive sequence current will have zero sequence current, because positive sequence current which is available before fault as well as during fault, therefore Zero sequence current, zero sequence also exists in case of line to ground fault. No need to confuse Satish. Now here 3, independent of grounding LL. Therefore, you tell me, even though grounding is suddenly changed in case of line to line fault, can you get the any mistakes? That means you are going to correct the answers. That means grounding is not necessary in case of line to line fault. This is the most important thing. Sandeep is replied, not necessary sir. Shiva also replied, no sir. Very good. Now tell me, everybody understand, even grounding is changes in case of line to line fault. Fault current expression or fault current calculation does not change because independent and grounding, but LG fault calculations will be changed. Therefore, LG fault grounding is necessary, LL fault grounding is not necessary. Now finally, electrical equivalent circuit. Electrical equivalent circuit for LL fault. In order to draw electrical equivalent circuit, we require the relation between voltage and current. Tell me what is the first relation? Both the voltages are equal, and second relation is currents IR1 equal to minus IR2. The first thing is there is a positive sequence and negative sequence component, no zero sequence. Therefore, positive sequence network I am developing right now. Positive sequence network reference is neutral. Therefore, induced EMF is ER1, current is IR1, reactance is X1 equivalent, and this is going to be terminal voltage. This is the positive sequence network of the synchronous generator, my dear friends. That is positive sequence network of the synchronous generator. Negative sequence network of the synchronous generator will have only reactance and there is no induced EMF. Induced EMF in the stator winding because of only rotor flux. And the current which is IR2, and this reactance is negative sequence equivalent reactance or driving point reactance. Now tell me how these two networks are going to be connected. Can anybody give the answer? This is positive sequence network, this is negative sequence network. How these two networks are going to be connected? Can anybody give the answer? I am waiting for your answer, my dear friends. How these two are going to be connected? Can give the answer? Anybody in the chat box, please reply. Please reply in the chat box. How these two are going to be connected depends upon the results. There will be first result as well as second results. Based on these two results, please tell me how to connect these two networks. Parallel. Lalit said parallel, Lakshmi parallel, opposite to each other. Opposite means parallel. Very good. Karthik parallel, Navyasri parallel, Satish has also said parallel. Okay, now see how parallel connection. These two terminals are connected once, and see faces are connected as well as neutral points also connected like this. Neutral point is connected like this, faces also connected like this. Now see here, between my two fingers the voltage will be VR1 here. The same voltage present across these 2 points also. Therefore, VR2 same as VR1. And one more thing, the current IR1, if you observe here, it is opposite to IR2. That is the reason why IR1 is equal to minus IR2. See here, IR1 is the current having same magnitude but opposite direction to IR2. Therefore, IR1 is equal to minus IR2. Now tell me, both the results are satisfied. Now tell me, in both the networks, what is the reference? Neutral is the reference. Whenever neutral is the reference, even though they are continuously changing the ground from reactance to solid grounding to isolated grounding to resistance grounding, it is not affecting neutral, because in positive and negative sequence calculations reference is neutral but not grounding. Therefore, LL fault grounding is not necessary. Even groundings are changed in case of LL fault. Even groundings are given in case of LL fault. Please ignore that groundings. Only consider positive and negative sequence calculations and complete the fault current expression in case of line to line fault. This was the complete discussion about line to line fault. I think everybody understood. Tomorrow I will explain what is the difference between solid fault of line to line fault. Today I explained LL fault with solid, and tomorrow I will explain LL fault with some fault impedance. What will be the difference in calculations? Tomorrow catch me live at 6 p.m. I think today we are going to be stopped right now. Okay. Please reply in the chat box if you really enjoy the class. If you really enjoyed the class, please press like button. Please press like button, my dear friends, and also please share to all your friends, and also those people also can get maximum information from me as a power system. I will try to give best out of best power system in the country. Okay, thank you dear friends. With your support, with your love, I am teaching like this in the country. Always your support is required. I can improve my energy levels, I can improve my subject like anything, right? Because always I am a good learner. Really thank you for all dear friends by patiently listening, and please share to remaining your groups and friends also in the Facebooks also. In the Facebook you have a group, share in that group our link, our class link, so that maximum people can utilize our classes. This is my request to each and every student. So please share our link to remaining your groups and your friends in the Facebook or Instagram, so that I can get maximum number of students, so that maximum students get benefit from us. Okay, and please subscribe to our channel, and if you really enjoyed the class, please press the like button and share to your friends. Thank you friends, good night all dear, see you tomorrow exactly at 6 p.m. Bye bye. Lalit Mahwar, yes sir, enjoying very much. Thank you Lalit. Srinath, okay sir. Thank you Srinath. Karthik, yes sir. Navyasri, enjoying sir. Shiva, thank you sir. Everybody thank you. See you dear friends tomorrow exactly at 6 p.m. Please share to your groups, right? And also join in my Telegram link. Okay, thank you friends. Bye bye. Good night.